Hey, I was just cleaning up some geometry. All right, so we're back to Algebra 1. Okay, so last week we talked about, not last week. Okay, so last lesson we talked about GCF, which is greatest common factor, and we're going to use those again to find the factors in these new polynomials. Okay, so this is going to have more than one term. Say we have 12mp plus, check my paper, 80m squared. Okay, so this is more complicated because remember, if we have a plus sign in our terms, this is now a binomial. It has two different terms, and we can't just add them together, and we can't do everything with these already set together. The first thing we need to do is do each piece separately. And we're going to do what we did in the last lesson, and we're just going to find the GCF for this one and this one. We're going to find the GCF between them, right? GCF stands for greatest common factor. So we're going to factor both of them and compare to see what's similar between them, just like we did on Tuesday's lesson, which was the 8 intro chapter. So I'm going to factor in red. So if I want to factor this 12, we just did this, it's 2 times 2 times 3 times m times p. Okay? Now if I want to factor 80, you might have to do your factor tree, right? Split it into 2 times 40, split the 40 into 2 times 20, split the 20 into 2 times 10, split the 10 into 2 times 5. Okay, so my ends of my tree, the ends of my branches, I've got 2, 2, 2, 2, and 5. So to save myself some space, I'm just going to write 2 times 2 times 2 times 2 times 5. So that's the number factored, and then I need to factor this m. So it's m squared, so there are 2 m's multiplying here. So now that we have these factored, we need to find the GCF, greatest common factor. So what factors do they share between them? Well, we have a 2 and a 2, so that's the same. We have another 2 and another 2, that's the same. We have a 3, but we don't have a matching 3, so we can't circle it. It's not shared. We have an m and a matching m, okay. M and m. We have a p and no matching p. And on this side, we have some extra 2's that don't match this side, a 5 and an m that don't have a match. So we're done. When we have our GCF, it's what was the similar between them? Oh, it was 2, a 2, and an m. 2 times 2 times m, that's 4 m's. Okay, so our GCF is 4m. Good. That's what we did on Tuesday. Now we go one more step. We need to take the remainders. What's left over after we took out the GCF? If I can get my green marker, there we go. So we look at our factors again. What's remainders? What's remaining there? Well, we have this 3p on this side. So a 3 and a p, that's one of them. Then we have a plus sign. And then we have a 2, 2, 5, and m. Well, what's 2 times 2? That's 4. 4 times 5, that's 20. m. We have that extra m on the end. So there's our remainders. Make it look like an m, not an n. We put the remainders in their own parentheses. Now we have our two answer pieces. We have two factors of our original polynomial. Right, this was our original problem we had here, and we factored it into two things it can multiply together to make it. Just like you can factor 10 into 2 times 5, we factored 12mp plus 80mp or 80m squared. When we factored them, we're going to combine them together. 4m, then parentheses, then we put a remainder after it. So we put the GCF in front and then the remainder. The remainder was 3p plus 20m. Okay, that is our answer. That's it. Now, if you want to make sure, if you do think, oh, maybe I mixed something up in here, you can check it by multiplying with the distributive property, right? So all we did in here was we did the backwards process of a distributive property. If you want to check it, you just distribute like normal, right? 4 times 3 would be 12. M times P would be the MP. Good. 4 times 20, that's 80. M times M is M squared. So everything, when we multiply it with the distributive property, it checks out. Okay, I'm going to do one example from the book. Or not the book, the assignment page. This is going to be number 1 on your assignment page. So it says, it gives you the polynomial 24x plus 48y. All right. First things first, GCF, which means we need to factor 24x. Okay, so you might need to do your factoring tree. That's okay. Luckily, I remember that 24 is 2 times 12. And I remember that 12 is 2, 2, and 3. So that's my 12. And I just need one more multiple of 2 to get back to 24. So if you do your factoring tree, you should get 2 times 2 times 2 times 3 makes 24. And then the x at the end. Okay. 48, same idea here. If I know that 48 is just 2 times 24, right? It's just double. I just need to take my 24 factors and add another 2 in there. Well, multiply another 2 in there. So 2, that's for doubling. Then I take the whole 24 factors. 2 times 3, and the y at the end. All right, GCF, so we need to circle our matching pairs. 2 and 2, well, I'll circle them. 2 and 2, another 2 and another 2, a third 2 and a third 2, a 3 and a 3, and nothing else matches, right? X, no match, and this 2 and this y are extras that don't have a match in the front, the first factors. All right. So our GCF is what we circled. 2 times 2 times 2 times 3. 2 times 2 times 2 times 3, which equals 24. Okay, there's the GCF. Now we need the remainder. What's left after we took the GCF out? We have an x. Okay, write it down. That's from our first set of factors. Then we have plus. Plus. And what's left in the second set of factors? A 2 and a y. So x plus 2y. That gets its own parentheses. We get to the last step, which is just combine it and make sure it's a good answer. So 24 is one piece of my answer, the GCF. And the other piece is the remainders here. X plus 2y. There's a good answer right there. And that was all number 1 on your practice problems. This is number 2 on your practice problems. So let me factor this. Starting here, what can I split 30 into? 6 times 5. But the 6 splits into 2 times 3 times 5. 2 times 3 times 5, that's 30. And these are all prime numbers. Perfect. Then we have times m. And then we have p squared, which means there are 2 different p's in our factors. All right, that one's done. M squared p. Well, this time the m is squared, so that means there are 2 different m's in my factors. And there's only 1 p in my factors. Okay? And then over here, negative 6p or minus 6p, 6 can be split into 2 times 3 times p. Okay. Now we check for GCF. So when we have 3 different sets of factors, right? 1 piece, 2, and 3, we need to check all 3 to see if there's a match for our GCF. So 2. There's a 2 at the end, but there's not a 2 to match in the middle. So no 2 circling. 3. Well, there's a 3 at the end, but this one doesn't have a 3. So we can't circle it. 5. Nope, they don't have 5s. M. Well, M here and M here, but this one doesn't have an M. So we can't circle it. A P. Well, here's a P, and this one has a P. So that one's good to go. We can circle P, P, and P. And I don't see anything else that they share. So the only thing that is GCF was a P. The only common factor, the greatest common factor, was just P. Okay. That wasn't too bad. Now we check our remainders. So we should have a lot of remainder since we only took out a P. We have 2, 3, 5, M, and P. Okay. 2 times 3 times 5 is 30, MP. So we've got 30 MP plus M times M is M squared. Okay, then we've got a minus and 2 times 3, which is 6. So that's the remainder, those 3 terms. So you'll notice your remainder usually has more than 1 term. It's hard to have a GCF in these ones. Later we'll have a lot of GCF of factors that have more than 1 term, but not today. All right. Now we're going to combine them and check. We have P. Right, we take this part and this part together. P, parentheses, 30. I don't like that 30. All right, P times the quantity of 30 MP plus M squared minus 6. Done. So that is our answer. Okay, so we're going to talk about a different way to factor when you've got an extended polynomial like this, right? We've got 4 terms here. And it is going to be very hard to find a polynomial with 4 terms that has 1 GCF. Usually it doesn't. And this one does not have 1 GCF. So what we're going to try to do is called grouping. Okay? We're going to look and say, maybe I can just do these 2 terms together, and then I'll do these 2 terms together, and that will be the best I can do for factoring. Okay? So we're going to check. The reason I picked these terms is that I thought about it and I said, oh look, these guys share an A. Remember, when we're looking for GCF, we want them to share some factor. These 2 terms share an A, maybe they'll have a nice GCF. And then I looked at these 2. Oh, nice. These 2 share a B, maybe they'll have a nice GCF. We don't know till we try, so sometimes you'll get your grouping wrong at first and have to try a second time. But let's try it out. So on the left side, let's factor it out. This will be my red group. The red group, I want to factor 6ax. It's going to have 4 terms. 6, I have to factor that into 2 times 3. Then we've got an a and an x. Okay? 3ay. That will factor into 3 terms. 3 is already prime, so that goes in our factors. Then an a, and then a y. So we're going through the same steps from the last board. We factor it, and now we look for a GCF. Okay? Well, what do they share? They share a 3, and they share an a. So my GCF will be 3a. Well, what step came after GCF, if you remember the other board? The next step is, what's the remainder? What are the remainders? Well, we have a 2 and an x left over. 2x. We got a plus y. Two x plus y. Okay. Then our last step was combine them and check them. 3a times the quantity of 2x plus y. So that's another way to say parentheses is the quantity of what's inside. It's another way to keep it clear what you're actually talking about. Okay. That was my red side, so this will be the purple side. Okay, so now we have to do the same thing for the other group. Now we have 2bx plus by. So let's factor. 2bx, I can split that into 2 times b times x. Those are the prime factors. Okay. 2 times b times x. Then I can factor by into b times y. Not too bad. All right. Next step, GCF. They share a b and nothing else. So our GCF is only b on this side. Okay. What are our remainders? We have 2x plus y then we put it back together and check. B times the quantity of 2x plus y. Okay. So in a grouping problem like this, we have two little problems we have to solve. We got one answer and one answer. Now we have to use our grouping to put them back together into two factors. So what you look at down here, look at this. The remainders on this side, 2x plus y. The remainder on this side, 2x plus y. It's the same. That's one of our factors. So your remainders should be the same, and they will go as part of our answer. Okay? Now, what we're looking for in a grouping problem is another binomial. We need two more pieces, two more terms to go in here. Well, I might want to take this term and this term and put them in there. 3a into positive b, so plus b. 3a plus b. Okay? That's our final answer. So our two factors are the parentheses here. What's in those parentheses? Okay, this is number 5 in your practice problems. I'm going to go through it, give a little bit of explanation, but so you can follow along while you do your practice problem. Okay, I'm going to group it into two pieces because I see these two might share something. They both have a y. These two, I don't know. It doesn't look like they share anything, but we'll talk about that later. I have to group them together, though, if I pick these two as a group. So let's factor. 6 turns into 2 times 3. Y squared means that there are two y's in the factors. All right. Now I got to split this 4y. It's going to be 2 times y. All right. I'm going to do all the factors first, then go through and do GCF. 3y, I can factor that into 3 times y. And 2, I can factor that only into 2. It doesn't get any smaller. All right, let's talk about GCF for the red group. This is our first group, so we're only looking at the two red factors. I've got a 2 that matches this 2, and I've got a y that matches this y. So my GCF here is 2y. All right, let's check on this side. Purple side, 3 and y and 2. What? They don't share anything. So there's an empty space. But when something's empty in math, unless it says 0, it's a 1, right? So the only thing they might share is that 1. Nothing else. That's the tricky part here. If you get a pairing, when you do grouping like this, if you get a group with no GCF, remember it's 1. You can put a 1 there. There's a lot of invisible ones in math. Okay, remainders. Here I have 3 and y minus 2. Okay, that's one remainder. Now remember, the remainders should be the same, so let's check. I've got 3y and 2 that I didn't use for GCF. So 3y, 2, and it's a minus. Oh, good. The remainders are the same. So I'm going to skip my combining step first, but if these are the same, that's one of our factors at the end. 3y minus 2. Okay. And our other factor is going to be the 2 GCFs. And they're going to be adding if this is a positive 1, which it is, right? We didn't take a negative 1 out. We just had an empty space. So 2y plus 1. And that is your answer. Those are the 2 factors of the original polynomial. Okay, and then for the last thing today, we're going to talk a little bit about how we can use these, what we just did, the factored polynomials, to solve equations. Okay? This all comes down to this very powerful tool we have in math. It's called the zero product property. And you already know this. You already know the answer to this, right? What's 103 times 0? Well, it's 0. What's 47 times 0? Well, it's 0. Anytime you multiply numbers by 0, you get 0. That means if you see that your answer is 0, you know that one of the 2 pieces has to be 0, right? If it's a multiplication problem. And all of our factoring gives us a multiplication at the end, right? Let's go look at the bottom of the last page. That answer to our factoring problem is 2 binomials multiplying, right? When we see the parentheses next to each other, that's multiplication. So every time that we factor, we get a multiplication problem, and sometimes it equals 0. Actually, a lot of the time, it can equal 0, and we can use this powerful tool, the zero product property. So let me give you an example. This is number 2. How does this work in reality? This is number 2 on your practice problems. It is. They've already did the factoring. So they already factored. They found out the 2 factors are 3m, and the other factor is m minus 4. And they said this is an equation where those 2 equal 0. Okay, so this part here, that's like an answer we might have gotten on the last board. 2 factors. 1 factor, 2 factor. Okay? And when we know that they equal 0, that means that this has to be 0 or this has to be 0. And actually, because there's 2 different m's in here, we're going to get 2 answers. There's an m here and an m here, a variable, 2 variables. We're going to have 2 answers. One of the answers is when this is 0, so the first factor equals 0. And the other answer will happen when this factor equals 0. So we solve these two small equations, right? We've done things like this before. If we can solve these 2 small equations, we will get our 2 answers to the big equation. 3 times something is 0. Remember, anything times, if the answer is 0, one of the things in the product has to be 0. 3 times 0 is 0. So 0, sorry. Okay, let's look at the first one. Let's solve it with our normal algebra skills. Divide by 3 on both sides. Those divide out. 0 divided by 3, well, that's still 0. Equal sign came down, and we had the m. So there's one of our answers. M equals 0. Now let's check the other one. All right, for this equation, we want to add 4 on both sides. So plus 4 plus 4. We get these add out. The m came down. Equal sign. 0 plus 4 is 4. And there's our other answer. So we found the two answers to our original solution, or original equation. And remember, why do we have two answers? Because we have two different places that are a variable. We have an m here and an m here. Each m could have a different number. This time they did, right? 0 for one of them and 4 for the other one. So this one had two answers. Okay, this is going to be number 3 from your assignment page in the practice problems. One of the factors they say is the quantity r minus 3. The other one is the quantity r plus 2. That's an r, I promise. And they said the whole thing equals 0. So if we want to use the zero product property, remember the end of it has to be equals 0. I mean, maybe the 0 is in the front, but it has to equal 0, or 0 equals. Because we have two parentheses next to each other, that means multiply. And if we're multiplying things, each one could equal 0. So let's split it up like that. Our first factor, r minus 3, well, that could be 0. And our second factor, r plus 2, that could be 0. And now we have two little equations that we can solve. So on the first one, add 3 on both sides. We get r equals 3. Okay, on the second equation, subtract 2 on both sides. We get r equals 0 minus 2 is negative 2. There's our two answers. Okay, this is number 6 from the practice problems, and this one's a little trickier. Right, they want us to use the zero product property, but they didn't give us a 0. It does not equal 0. But we can fix that. Okay? We can move these 25 t's over here to the left side with our algebra skills. If we subtract them from here, subtract 25 t's, subtract 25 t's, we'll get, well, t and t squared, they don't go together. So it needs to be 5t squared stays apart minus 25t. Equal sign. 25t minus 25t, cross them out. There's 0 t's left over here, so nothing left on that side. Whew. So nice. We have it equals 0. But we still can't use the zero product property until we have factors on the left side. So we need to factor. Now, I'm going to use a little bit of the faster way of factoring. I'm going to say, would you look at that? This has a t, right? And this has a t. So one of the factors is t. This has a 5, and 25 can divide by 5. So there's a 5 with that factor. Okay, now you can do this the same way we did on the other boards. I just wanted to go a little bit faster today. So if I take a 5 and a t out of 5t squared, all I have is that extra, the other t that's in that squared. So t minus 25 divided by 5 is 5. T divided by t, they're gone, right? They divide each other out. Equals 0. Now here we have two factors. We have 5t and we have t minus 5. And they both equal 0. So we can make 5t equals 0. And we can make t minus 5 equals 0. Solve them, and you will get t equals 0. And add 5. T equals 5. So there's my two answers for this one.